Hey everyone, today we are diving into a real workhorse in the software world, service-based architecture. We're going to break down what it is, exactly how it works, and maybe most importantly, when it might just be the perfect choice for your next project.
So, if you're in the software world, you've definitely run into this classic dilemma. On one side, you've got the good old monolith. It's simple to get started for sure, but man, it can turn into a tangled mess over time. On the other side, you've got microservices, incredibly powerful, super scalable, but also wildly complex and expensive. It really feels like you're stuck between a rock and a hard place. But what if that's a false choice?
Well, it turns out there is another way. It's called service-based architecture. And you can really think of it as the best of both worlds. It is a distributed architecture, so you get a lot of those sweet benefits of microservices. But you get to skip a lot of the headaches, the costs, and the complexity. It's all about being pragmatic, finding that balance. And that's exactly why it's so popular. So let's see how it actually works under the hood.
To really get what this style is all about, we gotta pop the hood and take a look at its fundamental anatomy, see what really makes it tick.
Okay, so here's the basic blueprint. You've really got three main parts. First, a user interface that's deployed all on its own. Second, a small handful of what we call coarse-grained services. These are bigger services that each handle a large chunk of your business domain. And third, a single shared database that they all talk to. See? It's a distributed system, but one that's already looking a whole lot easier to manage.
So, how many of these services are we really talking about here? Well, the sweet spot is usually somewhere between 4 and 12. And this is a super important point. It's enough services to give you that modularity and the ability to deploy things independently, but not so many that you're drowning in the complexity of managing, hundreds of tiny little services. It's a number that a single team can actually get their heads around, both for development and for operations.
And check this out. The flexibility doesn't stop with the back end. That UI we mentioned, it doesn't have to be one giant single piece of code. You can break it down too. You could have a separate UI for each business domain or even go a step further and have one tiny UI for each service. This gives you a ton of options for how you organize your teams and your release cycles.
So what does one of these coarse-grained services actually look like on the inside? Well, you can pretty much think of them as their own little mini applications. A really common way to build them is with a classic layered architecture. Your presentation layer, your business logic, and your data access layer. Or another really powerful pattern is to organize the code inside the service by business subdomains, which keeps everything super neat and tidy.
Okay, everything's sounding pretty great so far, right? But every architecture has its trade-offs, its kryptonite. And for this style, the biggest challenge by far is that shared database. I mean, when you have a bunch of independent services all relying on one single database, well, making changes can get a little tricky.
This right here illustrates a huge pitfall. This is the don't do this slide. If you lump all your database code into one single shared library, just look at what happens. You make one tiny change to a database table, and now you have to update that library. But wait, every single service uses that library, so now you have to redeploy everything. This totally torpedoes the whole point of having independent services. It is a major headache in production.
So how do we fix this mess? The answer is something called logical partitioning. It's actually pretty smart. You look at your database schema and you group your tables by business domain. All the orders tables go together, all the invoicing tables, all the customer tables. Then you create separate shared libraries for each of those domains. Now, if you change something in an invoicing table, only the services that actually care about invoicing need to be updated and redeployed. This contains the blast radius of any change, and it is absolutely crucial to making this architecture work well in the real world.
All right, diagrams and abstract concepts are great, but let's make this really concrete. Let's walk through a real-world example, a system for an electronics recycling company.
Here's the story of what happens. A customer wants to know what their old phone is worth, so they ask for a quote. They like the price, they send it in, and the company receives it. Then a technician assesses it to see if it still works. If it does, the accounting team sends the customer their money. The whole time, the customer can check the status of their item online, and finally, the device gets recycled. It's a pretty clear step-by-step process.
And bam! Now we map that whole process directly onto our architecture. Each of those distinct business steps, quoting, assessment, accounting, each one becomes its own independent coarse-grained service. You can literally see how the structure of the business directly shapes the structure of the software. That right there is the hallmark of really good domain-driven design.
Now, this slide shows off a really powerful idea called an architectural quantum. Notice how the whole system is split into two zones? There's the external part that customers interact with, and then a totally separate internal part for company operations. They even have their own separate databases. This is just fantastic for security because there's no network path from the outside world into your core internal systems, and it lets you scale the two parts completely independently.
So, we've seen how it's built, and we've walked through an example. Now it's time to put on our analyst hats and actually rate this architecture on its key characteristics. Let's see how it really stacks up when you look at the trade-offs.
And here it is, the scorecard. Now you'll notice something right away. There are a lot of 4-star ratings, but there are no 5 stars. And that's not a bad thing. That's actually the whole point. Service-based architecture is a jack of all trades, but it's a master of none. It's a fantastic all-around choice when what you need is balance and pragmatism. Let's dig into those high scores. Because you've broken the application into these domain services, each piece is just smaller and easier to test. That makes sense. Deployments are faster and a whole lot less risky. And because the services are pretty self-contained, if one service goes down, let's say the receiving service has a problem, it doesn't bring the rest of the application down with it. That gives you some excellent fault tolerance right out of the box.
But what about those lower scores? Let's talk about elasticity. That's the ability to automatically scale up and down based on demand. It only gets 2 stars. So why is that? Well, remember, the services are coarse-grained. That means when you need to spin up a new instance, you're replicating a lot of functionality. It's not nearly as efficient or as cheap as scaling up one tiny, single-purpose microservice.
So it all boils down to this fundamental trade-off. Service-based architecture gives you most of the really important benefits of a distributed system, like modularity, independent deployability, and fault tolerance, but it does it without the massive costs and operational overhead that comes with something like microservices. It's all about choosing pragmatism and simplicity over raw, absolute power.
And this brings us to the most important question for any architect, for any developer. When should you actually use this style? When is it the right tool for the job?
I just love this analogy from the source material. You could use microservices for just about everything, but sometimes it's exactly like buying a Ferrari just to sit in rush hour traffic. Yeah, it looks cool, but it's a massive waste of money and resources if you don't actually need that incredible level of power. Sometimes a good, reliable sedan is the much smarter choice.
So, this architectural style really shines in a few key scenarios. It's perfect when you know you need better modularity than a monolith can give you, but you want to avoid the extreme complexity that comes with microservices. It's a natural, almost perfect fit for applications that are designed using domain-driven design. And, crucially, because most of your business operations happen within a single service, it's much easier to use traditional, reliable ACID database transactions, which can be a huge headache in more distributed systems.
And that leaves us with one final question for you to think about for your own work. When you're sitting down to design your next system, ask yourself what it really needs. Does it truly require the absolute peak performance of a race car? Or does it need to be a reliable, cost-effective, and pragmatic solution for everyday challenges? The answer to that question will tell you if service-based architecture is the right road for you to take.